A very good morning to you, dear students. In the previous classes, that is in the previous videos, we learnt about Mendeleev's periodic table and what was the type of classifications that they followed before Mendeleev. Okay, so the earlier form of classification was the Dobrimius triads. Then after that, we had the Newland law of octaves, and next was a breakthrough in the classification of elements, and that was by the Russian scientist Dmitry Mendeleev. So after Mendeleev, we had the modern periodic table. So in the modern periodic table, we discussed about the periodic trends that were followed. Okay, and now we go to a very important part of the lesson called metallurgy. So when we talk about metallurgy, we should clearly understand the term metallurgy first. Okay, so when it is when you just discuss about metallurgy, it is not just one type of process that leads to the extraction of metals. That we should understand clearly. So the definition for metallurgy explains it very clearly, like the methods or the steps that are involved from the ore to the finished product. Okay, from the ore to the finished product. If, for example, if you are just talking about metallurgy of iron, the extraction of iron, it is not one single process. Okay, so there are many steps that are involved, like your mother making a cup of coffee, or your mother making a bowl of rice, for example. இப்ப அரிசி அப்படியே எடுத்து தண்ணியில போட்டு கொதிக்க வச்சு சாதத்தை வடிச்சிடலாமா? அந்த வடிக்கிறதுக்கு முன்னாடி ஒரு ப்ராசஸ் செய்யறோம். என்னது? அரிசியை அளவா எடுத்து தண்ணியில போட்டு அம்மா கழுவுறாங்க. தண்ணியில அரிசியை கழுவி எடுக்கும் பொழுது we have some process like அதுல சின்ன சின்ன ஸ்டோன்ஸ் இருந்தா அதை பொறுக்கி எடுப்பாங்க. தென் இந்த நெல் எல்லாம் முழுசா இருக்கும் சில டைம்ல அரிசியில. இது மாதிரியான ப்ராசஸ் முடிஞ்சு அதை தண்ணி ஊற்றி நல்லா கழுவுவாங்க. கழுவிட்டு அந்த அரிசி எடுத்து பாய்லிங் வாட்டர்ல போட்டு உப்பு ஆட் பண்ணி வடித்து எடுப்பது தான் ஒரு ப்ராசஸ் இல்லையா? இப்ப the steps that are involved பார்த்தோம்னா, first we do some hand picking to remove the stones that are present in the rice and the unwanted materials that are there. Then afterwards we wash it with water. Then afterwards it is put inside the cooker or whatever it is, the method adopted. Fine. So these steps that are involved in making the rice, okay, அதே மாதிரி தான் மெட்டலர்ஜி ஆஃப் அயன் சொன்னோம்னா, ஓர் இருக்குதுன்னா அது டைப் ஆஃப் ஓர் என்னன்னு செக் பண்ணணும். ஓகே, தென் ஆஃப்டர்வர்ட்ஸ் த பியூரிஃபிகேஷன் ஆஃப் ஓர், அந்த டிஃப்ரெண்ட் இம்பியூரிட்டிஸ் பார்த்தோம்னா வச்சுக்கோங்க, கெமிக்கல் இம்பியூரிட்டிஸ் இருக்கலாம், இல்ல மட் இருக்கலாம், இதெல்லாம் எப்படி ரிமூவ் பண்ணிட்டு தென் த எக்ஸ்ட்ராக்ஷன் ப்ராசஸ் இஸ் தேர் வேர் த பியூர் மெட்டல் இஸ் removed from its ore, and this entire process we call it as metallurgy. Okay, fine. இப்ப இந்த மெட்டலர்ஜி அப்படின்னு சொல்றது எல்லா மெட்டல்ஸ்க்கும் ஒரே மாதிரியான ப்ராசஸ் தானா அப்படின்னு ஒரு கொஸ்டின் ரைஸ் ஆகும். அப்படின்னா இட் இஸ் நாட், டெஃபினெட்லி இஸ் நாட் ட்ரூ. ஸோ இஃப் இட் இஸ் அயன், we follow a different set of procedures. If it is aluminium, we follow a different set of procedure. If it is copper, we follow a different set of procedures, and these three metals we are going to discuss about, okay, the extraction of these three metals in this lesson. Fine. So now you are going to watch a few videos this week. Okay, I am just going to compile some videos from YouTube and just put them together so that you will try to know what are the different types of process that are involved in the process of metallurgy. என்னலாம் இருக்கலாம்? So if it is a sulfide type of ore, froth flotation process is used. If it is a heavier ores, gravity separation is used. Like this, we have different methods adopted in the process of metallurgy. So metallurgy is not one single process. It involves different types of processes which we choose. Okay, the process, அதாவது அந்த டைப் ஆஃப் மெத்தடாலஜியை டைப் ஆஃப் ஓரை வச்சு சூஸ் பண்றோம். ஓகேங்களா? இப்ப இது ஒரு பகுதியில் இருக்கிறதுக்கு முன்னாடி இப்ப ஓர்னு நான் நிறைய தடவை சொல்லிட்டேன். ORE, understand? So ore has different sense when you are using it in your boat. Okay, ore அப்படின்னா அது துடுப்பு. ஓகே, படகை தள்ளக்கூடியது. இங்க ஓர்ன்றது ஒரு ரா மெட்டீரியல், அன்குக்டுன்னு சொல்லலாம். Okay, uncooked substance அப்படின்னா என்ன, அடுப்புல வச்சு சமைக்கிறது இல்லை, uncooked not processed. Okay, so when I am digging the ore from the earth, okay, that can have many minerals in it. Understand? இப்போ அதில் அயன் இருக்குது அப்படின்னு சொன்னோம்னா அது ஓர் ஆஃப் அயன் அப்படின்னு சொல்றதுக்கு சில தகுதிகள் சொல்றோம். There are certain set of properties. For example, I choose clay. Okay, clayன்றது களிமண் நம்ம எல்லாருக்குமே தெரியும். இப்போ களிமண்ல என்னென்ன இருக்குது அப்படின்னு பார்த்தோம்னா களிமண்ணுனாலே மண்ணுங்கிறதுனால it is a substance of silica. Okay, it may have some amount of moisture in it. Understand? Like this, there are few substances, and you should also know that a little of aluminium is also present. Okay, இப்போ அதுலேருந்து வந்து அலுமினியத்தை நான் எக்ஸ்ட்ராக்ட் பண்ணலாம். There is no difficulty in extracting aluminium from clay. Understood? But the process that is involved in the extraction process இருக்குது பாருங்க, that is expensive. இப்போ எதுவாக இருந்தாலும் ஒரு இண்டஸ்ட்ரி ஒரு மெஷினரி வச்சு செஞ்சு அதுலேருந்து செப்பரேட் பண்ணி எடுக்கும்போது the product that I am getting afterwards, extraction முடிஞ்ச பிறகு பார்த்தா the amount of aluminium நான் செலவு பண்ண அளவுக்கு ஒர்த்தான அலுமினியம் கிடைக்குமானா கிடைக்காது. அப்ப அதுமாரி லிட்டில் அமௌண்ட் ஆஃப் அலுமினியம் கிடைக்குது அப்படின்னு சொல்லும்போது அந்த அலுமினியத்தை நாங்கள் மார்க்கெட்ல எடுத்துட்டு போய் கமர்ஷியலைஸ் பண்ணும்போது the cost of aluminium will be very high. So the product when it is sold in the market, if it has to be easily assessed by the customer, the cost of the product should be less. அப்ப என்னுடைய ப்ராடக்டோட விலை எதெல்லாம் சேர்த்து டிரான்ஸ்போர்ட்டேஷன், எக்ஸ்ட்ராக்ஷன் அண்ட் மைனிங், மெட்டலர்ஜி ப்ராசஸ், அதுக்கப்புறமா அதை பேக்கிங் இருக்குது, அதில் ஒர்க் பண்ணுற லேபர்ஸோட சம்பளம், இப்படி பல விஷயங்களை அடங்கியது தான் ஒரு ப்ராடக்டோட விலை. இந்த ப்ராடக்டோட விலை மெட்டலர்ஜி ப்ராசஸை காம்ப்ளிகேட்டடாக ஆக்கிட்டோம் அப்படின்னு சொன்னோம்னா விலை அதிகமாக வச்சு தான் நம்மளால விற்க முடியும். The customer will be feeling it much difficult to get the product and use it. So I should adopt a process of metallurgy that is cheaper and easily to be extracted. அப்ப மெட்டலர்ஜின்றது நான் என்ன சூஸ் பண்ணுவேன் அப்படின்னா ஒரு ஓர்ல இருந்து அந்த மினரல் எடுக்கும் போது செலவு கம்மியாகவும் the process that is involved in the process of metallurgy should be easier also. அப்படி எங்க வந்து source of ore இருக்குதுன்னு தான் நான் பார்க்கணும். So a ore should be something that could be easily accessible. Okay, இப்போ இது மாதிரி பார்க்க பொழுது அதிலிருந்து கிடைக்கக்கூடிய மெட்டலோட அளவு அதிகமா இருக்கணும் அந்த ஓர்ல. அப்ப அதை தான் ஓர்னு சொல்ல முடியும். ஸோ மினரல்ஸ் அப்படின்னு சொல்றது தான் பூமியில இருந்து கிடைக்கக்கூடியது ஓர்ல. அப்போ வாட் இஸ் அ ஓர் அண்ட் அ மினரல் அப்படின்னு சொன்னோம்னா ஓர் இஸ் சம்திங் that is from where the metal could be easily extracted அப்படினு ஒரு definition இது ஓர்க்கும் மினரலுக்கும். Okay, now it is fine. This is the introduction to what we are going to learn. Okay, so I am just going to put some videos together and we will watch those videos this week, and when you find some doubts you will text me so that the next video I will be explaining the process plus the doubts that you are asking me. So the videos that I have chosen are very clear, okay, in their explanations, which you will understand much better. Don't have any doubts about it. But even then, you are supposed to ask me some questions which you don't follow, so that I will be able to explain that in the next video. Already a few doubts have reached me. Understand, there are some doubts that you are already asked, and I will be explaining those doubts in my next video. And before that, you will watch this so that we will add them all together, and it will be easy for me to make the next video. Okay, thank you. Now we will watch the videos and give your comments. Thank you.
Metallurgy. In this lesson, we shall learn about metallurgy and the process of obtaining pure metal from ore. The process used for extraction of metals in their pure form from their ores is referred to as metallurgy. Pure metals can be obtained from their ores through 5 steps. The first step of metallurgy is crushing and grinding of ores. Ores are crushed into a fine powder in big jaw crushers and ball mills. This process is called pulverization. After pulverization, the ores are concentrated based on the type of impurities and their percentage proportions. Removal of impurities results in concentration of the ores. Concentration can be done by any of the three methods. Centrifugation is done when there is difference between the densities of the ore and the impurities. In this method, fine powder of ore is placed on a moving table with slots and is moved rapidly such that the particles of metal remain in the slot because of centrifugal force. The dense ore particles settle down in the grooves while the lighter impurities are separated. Froth flotation is used to concentrate ores that are in sulfide forms. Concentration of sulfide ores of copper, lead and zinc metal are carried out by this method. The ore is taken in a large tank containing oil and water and is agitated with a current of compressed air. The ore, wetted by the oil, separates from the impurities or gangue in the form of froth. Heavy particles like clay, sand, etc. become wet and settle at the bottom. Hence, the sulfide ore is removed with sieves in a second vessel and washed with water. In magnetic separation, the pulverized ore is placed on a conveyor belt that has two magnetic wheels. The magnetic particles are attracted to the magnetic wheel and fall separately apart from the non-magnetic particles. Methods like roasting, calcination and smelting are used to convert the concentrated ore into metal oxide. Roasting is the process of heating the concentrated ore to high temperature in presence of excess air. Calcination is the process of heating the concentrated ore in absence of air at a temperature not sufficient to melt the ore. Smelting is a melting operation in which the constituents of the ore are in melted form. Next step of metallurgy involves reduction of metals. It can be done using reducing agents as well as by the process of electrolysis and thermal decomposition. Reducing agents like carbon or carbon monoxide are used to reduce zinc, iron, lead and copper oxides. When oxides of metals like iron, manganese and chromium are heated with aluminium, the corresponding metal is obtained by reduction. Electrochemical reduction method is used to obtain metals from oxides of active metals because these metals attract more oxygen than carbon. The metals produced by reduction still contain impurities. Further refining of metals can be done by electrolysis, liquefaction and distillation. Metals like copper, zinc, tin, lead, chromium, nickel, silver and gold are refined electrolytically. For refining of an impure metal by electrolysis, a thick block of impure metal is made the anode and a thin strip of pure metal is made the cathode. A water-soluble salt is taken as electrolyte. On passing current through the electrolyte, the impure metal from anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. The soluble impurity goes into the solution, whereas the insoluble impurities settle down at the bottom of the anode and is known as the anode mud. This method is used for refining of metals like tin, lead, etc., having low melting points. In this method, a furnace having slope is kept slightly at higher temperature than the melting point of the metal. The metal melts and is collected in the vessel kept below. The melting points of impurities are higher and so do not melt and are found in the solid form on the slope. If impurities are present in traces, the principle of fractional crystallization is followed. The refining of semi-metals like silicon, boron, etc. is carried out by zone refining method. The impurities are more soluble in the molten form. So as the molten metal cools down, the solubility of impurities decreases and separates out from the metal in the form of crystals.
In this video, we're going to learn about electroplating. Electroplating is the process of coating one metal object with another. It works by electrolysis, which is when electricity is used to drive a chemical reaction. We're going to look at why you would want to electroplate, how it works, and various conditions that need to be considered. So why would we want to do electroplating? Metals may be electroplated for aesthetics, protection, or both. Aesthetics might involve making a metal shinier or giving it an attractive colour by coating. For example, jewellery is often plated with gold or silver. A metal coating can be used for protection, as it may help resist corrosion, rusting, or just general wear and tear. Car rims are electroplated for both shininess and protection. Chromium, commonly known as chrome, nickel, tin, zinc, and cadmium are often used to plate copper, iron, and steel objects. Tin cans are actually made of steel, but have a thin tin coating. Ed White, the astronaut who made the first American spacewalk in 1965, was wearing a gold-plated visor to protect his eyes from the solar radiation. So how does electroplating work? An electric current is passed through a solution that conducts electricity, called an electrolyte. To create this current, two electrodes are dipped into the electrolyte solution and connected to a battery or power supply. So we end up with a setup that looks something like this. When the current is turned on, the electrodes gain a charge. The positively charged electrode is called the anode, and the negatively charged electrode is called the cathode. The electrodes in an electrolyte are carefully chosen based upon what metal you are plating with. So if you want to copper plate another metal, you will use a copper-based electrolyte solution, and have a copper anode. The copper for the plating comes from the electrolyte solution, which in turn has its stocks replenished by the copper anode. So let's look at copper plating as an example. We want to copper plate some brass. So we have a copper anode, a brass cathode, and a copper-based solution for the electrolyte. So copper sulfate solution. Copper sulfate solution contains blue copper ions and colourless sulfate ions. The copper ions are positively charged and so are attracted to the negatively charged brass cathode. The copper ions deposit onto the brass, producing the thin copper plate. The positively charged copper ions gain electrons, which is known as reduction. The sulfate ions are negatively charged and so are attracted to the positively charged copper anode. The current supplied to the anode causes the copper atoms to oxidize, which is lose electrons, and then dissolve into the electrolyte solution. So the copper ions move from the anode to the cathode in the solution, and the electrons move from the anode to the cathode, but along the wire. The copper anode bar gradually dissolves to replenish the copper ions in the electrolyte solution, so the solution stays at the same concentration. If another metal was used at the anode, then the copper sulfate solution would get paler or less concentrated. So just remember that oxidation, the loss of electrons, takes place at the anode, and reduction, the gain of electrons, takes place at the cathode. So a few other things to consider in electroplating. The speed at which electroplating occurs depends only upon the strength of the electric current. A stronger current increases the speed at which the ions and electrons move through the circuit, speeding up the plating process. One way to increase the current is by increasing the concentration of ions in the solution. It is also important to choose your metals carefully in electroplating. Not all metals will alloy with each other. For example, steel has to be copper plated and then silver plated because it will not form a direct alloy with silver. There are also environmental concerns associated with some metals. Chrome plating, for example, creates waste materials which are dangerous to humans and animals. Waste products have to be treated accordingly to make sure they are safe, which can be very expensive. And finally, most importantly, for current to flow, the ions need to be able to move. So the compound must be molten or dissolved in a solution. So in conclusion, from this video, you should understand how electroplating works using electrolysis. When the current flows, the positive ions in the electrolyte solution move towards the negative cathode where they gain electrons, which is reduction. And this is what causes the plating to occur. At the anode, the current causes the metal atoms to lose electrons and dissolve into the electrolyte solution. The electrons, which the metal atoms lose, flow back to the power source and around to the cathode. Losing electrons at the anode is known as oxidation. So just remember, we have reduction at the cathode and oxidation at the anode, and that's electroplating.
As you may already know, the Earth's crust is made of rocks. If you look closely at a rock, you will see that there are many different bits. Some bits are dull, whereas other bits are rather shiny. The main idea here is that all these components occur naturally. In other words, they are not made in a factory or by a human being. A naturally occurring element or compound is known as a mineral. Ore is simply a rock containing a high percentage of a certain mineral. For example, hematite contains a high percentage of iron. The extraction of iron from hematite is done in a blast furnace. Malachite contains a high percentage of copper. Cinnabar contains a high percentage of mercury. We can think about an ore a bit like a chocolate chip cookie. We really want the chocolate. If there are more chocolate chips in the cookie, then the extraction process would be more economically beneficial. As more minerals, in this case, the chocolate can be obtained. If there are fewer chocolate chips, then the extraction process may not be as economically beneficial. For the most part, the minerals are oxides, carbonates, or sulfides of the metal of interest. Some ores of nonmetals include quartz, which contain a high percentage of silicon in the form of silicon dioxide. Limestone is also an ore. Can you remember what is found in a high percentage in limestone? Pause, think, and continue when ready. The answer is calcium carbonate. Limestone contains a high percentage of calcium, but calcium exists as calcium carbonate. The iron in hematite is mostly iron 3 oxide. The copper in malachite is mostly copper 2 carbonate. The mercury in cinnabar is primarily found as mercury 2 sulfide. The extraction process for each ore can vary, but the key idea here is that the mineral must be present in a high enough percentage, or else the process would not be very economically beneficial. Now, before we can extract a selected metal, we must first consider its reactivity by looking at this reactivity table. The most reactive metals are at the top of the series, and the least reactive at the bottom of the series. Although carbon and hydrogen are not metals, they are still included in the table for comparison purposes. A more reactive element can displace a less reactive element in a compound. Can you remember what this type of reaction is called? Pause, think, and continue when ready. The answer is a single displacement reaction. So to extract a metal from an ore, a single displacement reaction must occur. We can mimic the extraction of copper from malachite using copper 2 carbonate powder. Copper 2 carbonate is a green solid that thermally decomposes to form copper 2 oxide and carbon dioxide upon heating. Copper 2 oxide is a black powder, and believe it or not, we can actually extract copper metal from copper 2 oxide. Place 3 spoonfuls of copper 2 oxide in a crucible and 1 spoonful of charcoal, which is essentially carbon. Heat this using a Bunsen burner with the crucible lid slightly ajar for approximately 5 minutes. While that is in progress, why don't you grab a piece of paper and a pencil and predict the products of this single displacement reaction. Pause the lesson and resume when ready. The carbon displaces copper in copper 2 oxide to give copper metal and carbon dioxide. Remove the crucible from the Bunsen burner and empty its contents into a beaker of cold water. Pour out the water and charcoal, rinse with water and repeat. This must be done when the mixture is hot, or else copper 2 oxide will reform. You will find little bits of copper metal at the bottom of the beaker. You have successfully extracted copper metal. In another lesson, you will learn how to extract iron using a form of carbon known as coke. Some metals, such as gold and platinum, are not found in ores, but rather exist naturally as native metal. Note that these are less reactive metals and therefore do not form oxide, sulfide, or carbonate compounds. In summary, an ore is a rock that contains a high percentage of a certain type of mineral, which can exist as an oxide, sulfide, or carbonate compound. The mineral can be extracted by a single displacement reaction using a more reactive element.